Okay, hello. So today too, I want us to see something about integration by parts. Okay, integration by parts. There is a shortcut for finding integration by parts, especially when we are dealing with an exponential function, a trigonometric function, multiplying some linear function, say x, or a quadratic function, say x squared. Okay, so, for example, like we've been given this question to solve by using integration by parts. Okay, so let's see how we can go by the integration by parts. Okay, so looking at this, we have the general way for solving integration by parts. I want us to see the shortcuts for it so that it will save time, especially when we encounter this in our MCQs. Yeah. So let's see how we can go about. Okay, so normally what we intend to do is that we make your the u, to be always equal to the one that will approach zero. So looking at this question, the one that will approach zero is x squared easily. Okay, so when you differentiate this, you are going to get 2x. When you differentiate 2x, you are going to get 2. When you differentiate 2, you are going to get 0. So this, you make this one represent your du, and the other one, make it represent the div. Okay, so your u becomes your s square, this your s square, and the div becomes your cos x. Okay, so you differentiate the values here until you get 0. So differentiate x squared, you are going to get 2x. When you differentiate 2x, you are going to get 2. When you differentiate a constant, you are going to get 0. Okay, and also you do that for its corresponding value. So for x squared, the corresponding value here is cos x. But here you rather integrate this part. So take note, to differentiate this part and you integrate this part. So when you integrate cos x, you are going to get sine x. And also when you integrate sine x, you are going to get minus cos x. Okay, so you integrate cos x again, but you know that anytime we integrate cos x, we are getting sine x, but because negative is here, so the negative will come, negative sine x. Okay, then we try to multiply them diagonally. So see how I have done it. You multiply them diagonally. So multiply this one by this, multiply this one by this, multiply this one by this. And also looking at the blue ink here, this what makes us easy for us to combine them. The first value takes the positive, negative, positive, negative, that way. Okay, so your s square, positive s square times sine x, you are going to get s square times sine x. Negative 2x times negative cos x, po, so you are going to get positive 2x cos x. Okay, then 2 times negative sine x, so you are going to get negative 2 sine x. So this becomes your final answer for the integration by parts for the question 1. So let's see how we can use it to solve the question 2. It's the same thing, the same approach. So you make your u to be your x, that the one that is easy, or that approaches easy 0 easily. Okay, then the dividend to be the other side, which is sine x. So when you integrate x, you differentiate the left part and you integrate the right part. When you differentiate x, you are going to get 1. When you differentiate 1, it's a constant, you are going to get 0. Immediately you reach 0, you stop. Then you come to its corresponding div. So the corresponding for x is sine x. When you integrate sine x, you are going to get minus cos x. Also, when you integrate cos x, you are going to get sine x, but because the minus is here, so the minus will come. Okay, so as I said previously, we introduce this sign, the blue ink, this sign for us to combine it easier. So the first one becomes my plus, this becomes my negative, this becomes my plus or the positive. Okay, so x, positive x times negative cos x, you are going to get negative x cos x, negative 1 times negative sine x. So remember, we are multiplying. Okay, we are multiplying the diagonals. So negative 1 times negative sine x, you are going to get positive sine x. And this becomes the answer to this integration by parts. Let's see the question 3. X, here it is in terms of an exponential fashion, x multiplying e exponent 2x dx. So similar, the x or the left hand side, this x easily approach 0, so we made that one to become u, and this one becomes my dividend. So you differentiate this until you get 0. So differential of x is 1. We differentiate a constant, you're going to get 0. You are done. Then anytime you integrate e exponent x, you maintain the e exponent x and you differentiate the exponent. But when you differentiate the exponent, you're going to get 2. Then you divide by the result. You are going to get half times e exponent 2x. Okay, so the same thing, you integrate this and that will give us 1 over 4 e exponent 2x, because the 2 will come and multiply the 2, and we are going to get 1 over 4 e exponent 2x. And the same thing, we multiply them diagonally. So here is positive, negative, positive. So positive x times half e exponent 2x, we are going to get this term. And also negative 1 times positive 1 over 4 e exponent 2x, we are going to get this term. Okay, but we can say e exponent 2s is common, so I can factorize e exponent 2s, and more or less half is also common, so that when you multiply this one by this, you are going to get this. So you can reduce this one to this. Okay, so very, very simple. Let's see the last question. So s cube multiplying e exponent x dx. Okay, so we, the same thing, we make our u to be my x square, x cube, and my dividend becomes my e exponent x. So dividend becomes my e exponent x, and my u becomes my x cube. Okay, so you differentiate this until you get 0. So it will get 3x square, then differential of x square, you are going to get the 2 come and multiply, you are going to get 6x. Then we differentiate 6x, you are going to get 6. We differentiate 6, we are going to get 0. So then you come to its corresponding dividend. Here to integrate the value. So when you integrate e exponent x, remember, when you integrate x with respect to dx, you are going to get 1. And e exponent x divided by 1 is still e exponent x. So you get e exponent x throughout. Okay, so you're going to get e exponent x, e exponent x, e exponent x, e exponent x. Okay, so after that, we just multiply them diagonally. So x cubed times x cubed times e exponent x, we are going to get this equation. Then negative 3, remember I said the first value becomes positive, negative, positive, negative, positive. Okay, that way. So positive x cubed times positive e exponent x, you are going to get this. Negative 3 multiply diagonally by e exponent x, you are going to get negative 3x square e exponent x. Positive 6x times e exponent x, you are going to get this x e exponent x. Then negative 6 times e exponent x, you are going to get negative 6 e exponent x. And we know that x, we can leave our answer like this, but we can simple, or we can reduce it. You know that x e exponent x is common. Yeah, so x e exponent x will come out, then leaving x square minus 3x plus 6 minus 6 over x, because when you multiply x e exponent x by 6 over x, the x will cancel the x, leaving 6 e exponent x, 6 e exponent x. Okay, so um thank you very much.